So this is the video key for the test that we took. So I'm just gonna go over, this is number one. So first question, find the number of potatoes in the sample with a weight of more than 200 grams. So just to refresh your memory, this is cumulative, so that is a full 100%. So more than 200 grams, right? This is where 200 grams is. If I go right here up, that number right there is 420, and this max right here is 760. So all we do is take those two numbers and subtract it. So 760 minus 420, that's going to give you 340 potatoes. Okay, find the median weight. So median is, we're taking this number and we are cutting it in half. So half of 760 is 380. So if we look over here, 380 is right about here. And if we go down, right, if we go down right here, all the way down, that is one, oh, that is horrible going. So this right here is 190. This goes up by 10, these go up by 20. Okay, so that is 190 grams. Find the lower quartile. So we already know that this is 380. So half of that is going to be 160. So 20, 40, 60. If I go straight across right here, and I look down, right, this is 110, 20, 30. Like you could say maybe a little bit more than 130. So 135, let's say, anywhere from 135 to 140 was the range for the lower quartile. And if we find the upper quartile, we do the same thing. We're looking to see where half of this is. So half of that, you could do this mathematically. The acceptable range for that was two. I saw a lot of people put 245. The range was between 242 to 247. Okay, that was acceptable. So for the next one, it says we're going to go ahead and take this and now put this into our box plot. So they tell us that the smallest weight is 20 and the largest weight is 400. So this right here is the largest weight, and 20 is going to be somewhere around here. So you could label it, it's 20, 400, good. And then if we go back, we said our median was going to be at 190. So we're going to go a little bit before 200 right here. Around there is going to be 190. That's where our median is. Median. Again, you could label it. Our lower was 135 to 140, and our upper, let's just say, is 245. So if I go over here, 135 to 140 would be somewhere around there. And our upper was 245, so that's going to be somewhere on around there. They did give a little bit of leeway for this. So you draw your box and you draw your whisker. So you connect that. Boom. There is your box and whisker plot. Done. It says you may assume that there are no outliers. Okay? All right, next. So the next one we're going to do is, this is a straight calculator question. So if it says, but you do need to know a formula for this, right? So the formula for this one is going to be, since we're looking at the lower, right, and the upper right here, and 25 would not be considered an outlier. That is on the lower end of the scale. So the formula for the lower one is going to be whatever your, sorry, I had to do something real quick. So the formula is going to be, you take your lower quartile, so first quartile, and then it's going to be minus 1.5 times the IQR. So we wrote that down on our index card, hopefully. So the first quartile is 62. So we're going to go 62 minus 1.5 times. And to find our IQR, interquartile range, that is going to be our Q3 minus Q1, which is our upper quartile minus our lower. So 88 minus 62 is going to give us 26. Okay, so 1.5 times 26, 26. And when you take this whole thing, plug this into the calculator, you are going to get 23. If you want to do this by hand, 1.5 times 26 is equal to 39. 62 minus 39 is equal to 23. So if it's lower than 23, it would be considered an outlier since 25. So all you have to write for this is since 25 is higher than 23, it is not an outlier. Okay, that's what you need to actually write. It says show. So that is demonstrating it. For this next one, a lot of you got this correct. Acceptable answers for this is that you could have said that the median for the evening, right? So this is the median for the evening classes. That is clearly higher than the median for the morning classes. So you definitely should have said that. But you should have also said that because it's asking you for the spread. Um, so if you look at this, the spread of this one right here is going to be higher than the spread of this. So you could have said the median for the evening classes is greater than the median for the morning classes, as well as the spreads are more spread out in the evening than it is for the morning classes. The lowest scores are in the evening. If you look, here's the lowest score, right? They are in the evening. And that is some things that you can go ahead and give, support the researcher's opinion as well as counter it. All right. For this next one right here, again, most of you got this correct, but we forgot what cumulative frequency is. Cumulative frequency is basically this one goes right here, and you're adding. So what are we adding? We're adding 15 plus 25, and that gives us 40. So that's what goes here. 40 plus 10 gives us 50. That was basically your 2 points, okay? Then it says, write down the probability that a bouquet of roses sold is not small. So how many of them are small? 15 out of 50 are small, right? So to find out how many are not small, you do 50 minus 15, which is 35. Out of 50 are not small. So that is the correct answer, okay? This is how much are small. This is how much are not small. There are a bunch of different ways to do this one. That's just the way I did it. You could have just added 25 plus 10 is 35 out of 50 altogether. All right. For the next one, it says find the probability that there are 12 roses in this bouquet. So the customer buys a large bouquet. So if we take a look at that one, right? How many large bouquets are there? Okay. So there are 10 large bouquets, and how many of them have 12 roses in the bouquet? We have to go back to the table for that, right? There are 4 of them that have 12 roses in that bouquet. So 4 out of 10. You could have written 4 out of 10. You could have written 40%. Any of them would have been fine. 0.4. So 40% would have been fine. You could have written 0.4. Any of those answers would have been fine for this. All right. For the next one right here, find the exact value of p. The easiest way to do that is take all of these numbers that we have, this one, this one, this one, and this one, add them up, and then subtract it from 1. So 1 minus the sum of all of that, and when you do that, you would have gotten 4 out of 18. You should actually do that yourself to make sure. 4B. All right. He is playing the game once, so calculate the expected score. So we already know that this number right here is 4 out of 18. So you take -3 times 1 over 18, -1 times 4 over 18, 0 times 3 over 18, so on and so forth, and you add those numbers. So what do I mean by that? -3 times 1 over 18 plus -1 times 4 over 18 plus 0 times 3 over 18, right? So on and so forth until you do 5 times 7 over 18, and you add all those numbers, and when you do that, you're going to get 1.83, or something that is equivalent to that. So 3 significant figures, okay? This one right here, this question that we're going to do right now, 4C, was the hardest one in the whole, probably the whole test. So he plays the game twice and then adds the 2 scores together. So find the probability that he has a total score of -3. So remember, right, to get a -3, right, if you take -1 and 0, that's not going to give you -3. The only combination to give you a -3 is going to be -3 and 0. Right? If you do -1 and 0, that does not give you -3. So the 2 things you could have had is the probability of getting a -3 on the first one, and then getting a 0, Or you could have had a probability of a 0 first and then getting a probability of -3. Those are the two situations. So what is his chances of getting a -3? That is 1 over 18. And, so the word and means to multiply. The probability of getting a 0 is 3 out of 18. Right? The word or means to add. If you got the 0 first, that is 3 out of 18. And if you got the -3 second, that is times 1 over 18. And when you plug this into the calculator, you're going to get either 1 out of 54. You could have gotten 0.0185. You could have gotten 1.85%. So any of those answers would have worked. Okay. The next one right here, this one, they're giving you the mean, they're giving you a standard deviation, and they're asking you for a weight that is greater than 90 grams. So you need to pull your calculator out and do normal CDF. Normal CDF. For the lower bound, it is 90. For the upper bound, you pick the number that is the biggest number you can think of. Like I told you, always just use nines, da da da, comma, then you put the mean, which is 85, and then you put the standard deviation, which is 7.5. Okay, you hit enter in the calculator, and that will give you a number that is about, I think it's 0.2 something. Yeah, 0.252 is what I got when I did that. 0.252. Again, you should do this in the calculator yourself and make sure that you get that. Okay. For the next one, so, well, the last one. All right. I don't know why, but a lot of people didn't do this one, even though it is probably the easiest question on the whole test. So for median, again, is, well, probably we ran out of time, but anyway, this is out of 200, right? That is the highest, so half of that median is the number in the middle. So if we go, they're asking us for the median length, so we got to go down like this, and that answer was 9 centimeters was the answer for that question. And write down the number of leaves with a length less than or equal to 8. So here is where 8 is, and that is 40. Okay, so the correct answer for this was 40 leaves. And remember, cumulative frequency means that all of these are already added. Okay, done.